Hey, welcome to our channel once again. So today's topic is, as you can see, linked lists. So it is a bit higher level of coding. So today's video will not be helpful for beginners because this is in the syllabus of BTech and BSc level. So I got many requests from our viewers that do some videos on linked lists, at least for single linked lists. So I'm covering up the single linked list topic this early, so for them actually. So I'll cover up the topics that I left behind for the arrays, structures, and all I left behind. I know that many topics are left. So after covering this single linked list, I'll go back to arrays and structures and all. I'll cover up that and then again go into the higher subjects. So okay, let us start with this topic. So a linked list. So what we know about lists, when you go for shopping, we make a list of things that we want to buy. Like, for example, if I want to go for grocery, I make out a list. I write a list and note down all the necessary things that I want to buy, and that is necessary for the household stuff, right? So list, that is what a list is. And what is this term? This is called linked list. Like, for more specifically, the lists which are linked, right? For example, what kind of list it can be? It can be like, let's consider this is a piece of paper and milk, blueberries, something like that, and jam, etc., like that. So this is a list, right? And in this list we have milk, blueberries, jam, right? So in this list the datas are milk, blueberries, and jam. These are datas, right? These are informations that I need to operate when I reach the grocery store, right? That's what a list is. So in case of linked list, datas are stored in this kind of structure. Linked list is a type of data structure actually. For example, there are many kind of linked lists actually. Today we're going to talk about single linked lists. Like, this video would be a bit long, so I will break it into part. I will make the part 1 and release the part 1 now, and then I will release the part 2, and then I will release the part 3, and so on. Let's see how many parts I can break it into. So these are the datas, right? And similarly, in case of computers, if I want to store some data inside it, so I can follow a manner of this single linked list, this kind of data structure, like assuming that you know what are the basics of data structures, because linked list topics is a bit higher on. So jumping onto that topic directly will be is a big jump from the primary level to a secondary level, right? Like that. So assuming that you guys know what data structures are and what structures actually do, well, I'll cover those topics obviously. After covering this, I'll go back to the previous ones like I was doing with the basics and all. But alright, this is for some of our viewers. So this is a linked list, and it is a kind of method that we can use to store data. So how does it look like? I'm talking about single linked lists, right? So So this is a singly linked list actually. Now what these things are. So these boxes are called nodes. What is a node? A node is a store machine, you can say. It stores values. Now what kind of values it stores? It stores two kind of values. I draw this line, I choose this line here. So one part is data and this part is address. It stores two kinds of data. One is the main data actually, which are like this: jam, blueberries, milk. So this is the data part. And what is the address part? This address part stores the address of the other node. Now assuming that you guys know what pointers are and what addresses are, if not, then I'm telling a bit, because I'm jumping into this topic, right? So it might be difficult for some of our viewers to connect with it. So I'm just giving an overview what an address is. So when I store some data inside a computer, those data are stored inside in some addresses inside the CPU. Maybe if I store 15, 17, or maybe 19, if I give input these numbers into the computer, these numbers are stored in specific addresses inside the computer. Maybe this address is 1001, 1002, 1003. These are the addresses where these nodes or these datas are stored, right? So in case of this linked list, there are many nodes, right? There can be infinite number of nodes. I drew just 3, but that's not it. It can be more. So this is the first node, this is the second node, this is the third node. So what is this thing doing? Firstly, I entered a number, say 5. It has some address. Now another number, say 6. Now this address part of 5 will store the address of this second node of 6, right? Now again, this nodes of 6 have an address part. This address part will store the address of this node. This node, say 7. So, and this address part is null, is grounded. I grounded this address part. That's how a singly linked list works. The last node of a singly linked list will be grounded, and each node of a singly linked list will store the address of its next node. For example, the next node of 5 is 6. It is storing the address of 6. Again, 6. The next node of 6 is 7. So the node of 6 will store the address of 7. And the last node is 7. So the address part of 7 will store a null value, or we can say grounded. Now the first node of any linked list, we call it head, or the starting point of the linked list. In all kind of linked lists, doubly circular, singly, circular, any kind of linked list, this first node we call it head. Alright, but in case of only singly linked list, this last node will store the address of null. I hope I'm clear about it. So that's how a singly linked list work. We'll do coding. I will show you how the code works and how the code looks like. I will write code. We will solve examples of many kind of operations of linked list, deleting node, adding node. So I'll cover up in different videos, so don't worry. So that's how a linked list work. So now how can I define a linked list? And now I am assuming that you guys know how structures work. So linked lists are defined by structures. Like we have to define a predefined data type, like the data type using structures. So a predefined data type is needed, right? So we can write something like, it would be type def struct node int data and struct node pointer next. That's how we define a structure. So what is this thing doing? Actually, by these 3 lines we have actually created a node, right? How did we do that? I have defined the structure assuming that you guys know how structures work, because this topic is a bit higher, so I can't cover up all the structures topic in this video. So assuming that you guys know structures and how pointers work, I will cover up those topics after completing this linked list, the single linked list part. So by these 3 lines we have created a node. A node has been created. Type def struct, I have named that thing as node. In data, this node has 2 parts that I have written over here. Int data, the part where the data will be stored, like I told that in any node there is a data part and there is an address part. So this data part has been created by this line, and this address part has also been created, which will store the address of the next node. So why this struct node thing? This is the struct node is a variable, is a data type that we have created. So it will store the value, it will store the address of the same type. Like the pointer, a pointer is defined like asterisk the variable name. For example, this is a pointer. Any variable that we write after this asterisk symbol, so that becomes a pointer. So this pointer will store the address of the same data type. So that's why we have declared as struct node in case of star next. So in data it has 2 parts and struct node is created. So that's how the things are working. And type def struct, and this next part, why I have written here next? Well, that's not necessary. Obviously we can write any variable and any name. So this next part will store the address of the next node, right? So that's it for today. So I have created a node. I told you how a linked list works. So here I'm ending the first part of this video. So in the next part we will implement that how to create a linked list, and then how to display, obviously how to create and display, and then onwards we will solve those different types of things, different types of implementation of codings and like implementation of linked list. So I hope up to this things are clear, right? And another thing that I want to say, which is not necessary, obviously, that when I'm declaring, when I'm just starting to make a linked list, we have to declare the head. The head should be a pointer, because I have to declare that the first node that I have should be null. Like how the mechanism works, I want to show you that. Like for example, if I make a first node, like if I enter the first value, let it be 5, it will be stored inside this node. It will be stored like this. Now what will be the address part? This address part will be pointed like this. Then again I want to enter 6. Things will be like this. Address part will store the address of next value. 6 will be here and it will point towards null. Again, if I want to store 7, sorry, this is the address part. This will store the address of 6. It will store the address of 7, and 7 will be stored. 7 will store the address of null. So this is how the mechanism works. This is how a linked list, a single linked list, is created. It's a very easy topic. It's not that hard, like it sounds like, but it's very easy. So, well, let's end this video right here, and we will discuss the next part of this video, obviously, in the next few videos. So, in next videos we will implement the code. We will write the code on computer. So I hope up to this things are pretty clear. So I hope you like the the video, and please like, share and subscribe. And this video is obviously not for the beginners, so it's for some of the viewers who know the basics of coding and wants to pursue this higher codes. So okay, from next video onwards we'll continue with our codes, right? So okay, please like, share and subscribe. So meet you in the next video.